Welcome, 8th graders. Today we are going to be looking at identifying key features of quadratic functions in standard form. If you remember, earlier in the school year, we gave you guys a sheet. It was a table that broke down quadratics into standard form, vertex form, and intercept form. Well, today I've taken an excerpt from that of just our standard form because this table can be very helpful in helping us identify the x-intercepts, the vertex, both the x and the y coordinate, the axis of symmetry, and the y-intercept. So today we're going to use this table to find our roots or our x-intercepts, our vertex, our axis of symmetry, and our y-intercepts from quadratic equations in standard form. Now that we've taken a look at our table and how helpful it can be in identifying key features from quadratic functions in standard form, let's use it to complete our first example for today. Here we have x squared minus 2x minus 35. To find our x-intercepts, we have a few options. We can use the quadratic formula, we can complete the square, or we can factor. Today, we're going to use factoring to find our x-intercepts. Step 1, I've outlined the steps here. Step 1, take out your GCF. In our case, our equation does not have a greatest common factor, or its greatest common factor is 1, so it would not change anything. Step 2, make an X puzzle or use the area model. You can use whichever one you prefer. I'm going to use an X puzzle today. To set up an X puzzle, we need to do A times C on the top and B on the bottom. So A times C, our A is 1, and our C is negative 35. So negative 35 times 1 is negative 35. And our B value is negative 2. Negative 2. Remember, we have A, B, and C. To complete our X puzzle, we need to find two numbers that multiply together to give us A times C, or our top number, and add to give us B, or our bottom number. So what two numbers multiply to 35? I'm going to start there. Well, we have 35 and 1, but there's no way that could add to give us negative 2. We have 35 ends in a 5. It's divisible by 5. 5 times 7. Let's try that. 5 times 7 is 35. We need to make one negative. So negative 5 times 7 is negative 35, so that works. And then negative 5 plus 7 is positive 2. Oh, that doesn't work. Maybe we switch the negative sign. So 5 times negative 7 is negative 35. 5 plus negative 7 is negative 2. So both of them work. So now that we've completed our X puzzle, we move on to step 3, which is to solve. This is going to change the signs. So I can go ahead and write my answer because I know that we're just going to change the signs and that my x-intercepts are positive 7 and negative 5. It would like us to find the vertex of the same quadratic functions. Let's go to our table. We see the vertex is broken up into the x value and the y value. So for the x value, we do x equals negative b over 2a. All right, so what is our b? That's right, we have our a is 1, b is negative 2, and c is negative 35. So negative b, negative 2, divided by 2 times a, which is 1. So minus negative 2 would be a positive 2, divided by 2 times 1 is 2. Well, 2 divided by 2 is 1, so our x value of our vertex is 1. Next, we need to plug in x and solve for y. All right, so our equation, we plug in our new x value. So we have 1 squared minus 2 times 1 minus 35. Set equal to y. So you can either use your technology and type that in your calculator, or you can work it out manually. So 1 squared is 1. Negative 2 times 1 is negative 2. And we can bring down our 35. So we have 1 minus 2, which is negative 1, minus 35. So y equals negative 36. So our vertex would be 1, comma, negative 36. Now that we've used our table to find our x-intercepts, or our roots, and our vertex, let's use it to find our axis of symmetry and our y-intercept. So looking at the table, axis of symmetry, it says x equals negative b divided by 2a. Well, that's the same thing that it said for vertex, the x value of our vertex. So I think it's safe to say that our axis of symmetry is equal to the x value of our vertex. So our axis of symmetry, x equals 1. And remember, guys, your axis of symmetry will always be an x equals number equation. And our y-intercept. Well, let's look back at our table, and what does it say for y-intercept? It says the y-intercept is our c value. So what is our c value? Our c value is 35, negative 35. So our y-intercept will be 0, comma, negative 35. It's the c in standard form. Now let's take a look at our first practice problem. Y equals 2x squared minus 8x plus 6. So why don't you guys pause the video and take a moment to find your x-intercept, your vertex, your axis of symmetry, and your y-intercept of this equation. Great, now that you've paused the video, let's take a look at our answers. So we found our x-intercepts by factoring. We needed a number that multiplied to give us positive 3 and added to give us negative 4. So negative 3 times negative 1 is positive 3, and negative 3 plus negative 1 is negative 4, so that works. We used our formula found on the table for vertex, x equals negative b over 2a. And then we simplified, and then we plugged in x to solve for y to get a vertex of 2, comma, negative 2. For the axis of symmetry, we knew that our axis of symmetry was equal to the x value of our vertex. And lastly, we knew that our y-intercept was the c in standard form.